Hi students, in the part of bridge course, today we will learn reflection and refraction of light, a very interesting phenomena of the light. By the end of this session, you will learn reflection of light, laws of reflection, types of images, refraction of light and laws of refraction. First of all, we will see what is light. Light is a form of energy which causes the sensation of vision to us. When light falls on a object reaches our eye, then we can see the object. Students, remember, light is neither a wave nor a particle, but it has dual character. Light has particle character as well as wave character. Here we can see light is an electromagnetic wave, it travels in the form of wave. It emitted or absorbed by the object as a particle, but it propagates as a wave. Here we learn two properties of light. In that, first one is reflection, second one is refraction. First of all, we will see what is reflection of light. When light falls on a smooth polished surface, it rebounds back. This phenomena is called reflection of light. Here we can see mirror. A ray which falls on a mirror is called incident ray. The point where it falls on the mirror is called point of incident. A ray which is reflected from the mirror is called reflected ray. If you draw a perpendicular to the mirror at the point of incidence, that is called normal. The angle between normal and incident ray is called angle of incident, represented by angle I. The angle between normal and reflected ray is called angle of reflection, represented by angle R. Now, we will see laws of reflection. There are two laws of reflection. In that, first one is the incident ray, the reflected ray and the normal at the point of incidence lies in the same plane. Here we can see mirror, this is incident ray, reflected ray, normal. These three rays lies in the same plane. This is first law of reflection. Second law is angle of incidence is equal to angle of reflection. The angle between normal and incident ray is the angle of incident. The angle between normal and reflected ray is the angle of reflection. Angle of incidence, angle I is equal angle R. These are the two laws of reflection. Here we have to note that when light ray incident normally on a plane mirror, it retraces its path. Retraces means it travel along same path with opposite direction. Here we can see light ray incident normally on a plane mirror, then it retraces its path. In this case, angle I and angle R both are equal to 0 degrees. Why angle of incidence should be equal to angle of reflection? This was explained by a French mathematician and amateur lawyer, Pierre de Fermat. This principle is called Fermat principle. Here we can see a plane mirror, this is a point A and another point B. Here C, D, E, F are the 4 points on the mirror. Here the condition is light from point A travels toward the mirror by hitting any one point out of 4 points, and it should reaches point B in a short period of time. Students, here observe the path of the light rays and observe the light ray which takes least time to reach point B. Here 4 rays are travelling toward the mirror and it reaches point B. Among these 4 rays, AEB is the path which takes least time to travel. If you draw a perpendicular at point E, we can observe that AEB is the path that takes least time to travel. So, angle of incidence is equal to angle of reflection. By using Fermat principle, we can prove that angle of incidence is equal to angle of reflection. Now, we will see image. What is image? The point where the light rays coming from the object meet or appears to meet after reflection or refraction form an image. Here candle is the object, light rays are travels toward mirror, after reflection they will converge and they form image. This is the image. Images are classified into 2 types. In that, first one is real image, second one is virtual image. Now, we will see the difference between real image and virtual image. First of all, we will discuss about real image. What is real image? Image which can be caught on the screen is called real image. Real image is always inverted image. Students, remember, real image is always inverted image. Real image is formed by converging light rays after reflection or refraction. Here we can see object, light rays from the object travels toward the mirror, after reflection they will converge at a point. So, it forms real image. Real image is always inverted image. So, here we can see candle is appeared as upside down. Image formed by a projector is the example for real image. Here we can see image formed by projector in our school is the example for real image. Here you may get one doubt, real image is inverted image, but in projector we will see erect image on the screen. How it is possible? Due to reversing the projector, we will get erect image, but students, remember, real image is always inverted image. Now, we will discuss about virtual image. Image which cannot be caught on the screen is called virtual image. Students, remember, virtual image is always erect image or upright image. Here we can see image formed by plane mirror is the virtual image. When we observe our image in the plane mirror, we can see our image, but if you place a screen behind the plane mirror, we can't get image on the screen. Virtual image cannot be obtained on the screen. Example for virtual image is image formed by plane mirror. Virtual image is formed due to diverging of light rays after reflection or refraction. Real image is formed by converging light rays. When 2 or more light rays meet at one point, then we call them as converging light rays. Real image is formed by converging light rays. If 2 or more light rays split from one point, then we call them as diverging light rays. Virtual image is formed by diverging light rays. Here we can see plane mirror. Here we took this person as the object. You can take a person or a candle or a tree or any object. Light rays from the top of the object travels toward the mirror and they undergo reflection. For the observer, these light rays are appear to coming from this point. Light rays from the bottom of the object travels toward the mirror and they undergo reflection. For the observer, these rays are appear to coming from this point. So, image is formed at this point. Here light rays are appear to diverging from a point. So, it is virtual image. Virtual image is always erect image. Example for virtual image is image formed by plane mirror. Now, we will see the properties of image formed by plane mirror. In that, first one is image formed by plane mirror is virtual and erect. Plane mirror always forms virtual and erect image. Size of the image is equal to size of the object. In case of plane mirror, height of the image or size of the image is equal to the height of the object or size of the object. Distance of the image from the mirror is equal to the distance of the object from mirror. Whatever the distance the object is located in front of the plane mirror, the image also formed with same distance from the mirror. Fourth one is image formed by plane mirror is laterally inverted. What is meant by lateral inversion? Left side parts of the object are appeared as right side on the plane mirror. Right side part of the object are appeared as left side on the plane mirror. This is called lateral inversion. Plane mirror forms laterally inverted image. These are the four properties of the image formed by plane mirror. Now, we will discuss about refraction of light. Before going to discuss about refraction of light, we will learn what is medium, what is rarer medium, what is denser medium. First of all, we will see medium. A substance through which light can pass is called medium. Example for medium is air, water, glass, diamond, etc. Light can pass through air, light can pass through water, light can pass through glass, light can pass through diamond. So, they are considered as medium. Mediums are classified into two types depending upon their optical density. In that, first one is optically rarer medium. A medium in which speed of light is more is called optically rarer medium. Second one is optically denser medium. A medium in which speed of light is less is called optically denser medium. For example, water is optically denser than air. If you consider air and water, air is the rarer medium, water is the denser medium. If you consider glass and water, glass is the denser medium, water is the rarer medium. If you consider diamond and glass, diamond is the denser medium, glass is the rarer medium. By considering only one media, we can't say whether that medium is rarer medium or denser medium. Now, we will see what is refraction of light. The process of change in speed at an interface when light travels from one medium to other medium, resulting in a change in direction of light is called refraction of light. Here we took two media, one is the rarer media which is in white color, second one is the denser media which is in light blue color. Here interface is a separating line between two media. This is the normal, a perpendicular drawn to interface is the normal. When light travels from rarer medium to denser medium, here we can see it bends towards the normal. Why it bends toward the normal? In rarer medium, speed of light is more. When it enter into denser medium, speed of light suddenly decreases. Due to that, it bends toward the normal. The phenomena of change in direction of light when light travels from one medium to other medium is called refraction of light. Here we can see the angle between normal and incident ray is called angle of incidence, represented by angle I. The angle between normal and refracted ray is called angle of refraction, represented by angle R. Example in daily life for refraction of light. First one, when a pencil is dipped in water, the parts of the pencil in air and water appear disjoint. Here we can see when a pencil is dipped in water, the parts of pencil in air and water appear disjoint, or the pencil is appear to be bending due to refraction of light. Second one, a lemon kept in a glass of water appears to be bigger than in size when viewed from side of the glass tumbler. Here we can see when a lemon is placed in a glass of water, the lemon appear bigger than its actual size due to refraction of light. Third one, when a glass slab is placed over some printed letters, the letters appears raised when viewed through glass slab. Here we can see when a glass slab is placed over printed letters, letters appears to be raised. And another example, when a person standing in a clear pool of water, the bottoms look raised and legs appear shorter. Here we can see when a person standing in a clear pool of water, the bottom appear to be raised and legs appear shorter. These are the example for refraction of light. Now we will see one activity. For that, take a shallow vessel with opaque walls. Place a coin at the bottom of the vessel. Move away from the vessel until you can't see the coin. Stand there. Ask your friend to fill the vessel with water. When the vessel is filled with water, the coin comes back into view. Here we can see a coin is placed at the bottom of the shallow vessel. When it is filled with water, a coin comes back into view due to refraction of light. Students, remember, when light travels from rarer to denser medium, it bends towards the normal. Here rarer medium and denser medium are there. When light travels from rarer medium to denser medium, it bends towards the normal. Here V1 is the speed of light in rarer medium, V2 is the speed of light in denser medium. N1 or neta 1 is the refractive index of the rarer medium, N2 is the refractive index of the denser medium. Students, remember, refractive index of denser medium is always greater. So, N2 is greater than N1. Speed of light in rarer medium is always greater. So, V1 is greater than V2. When light travels from rarer to denser medium, it bends toward the normal. So, in this case angle of incidence is greater than angle of refraction. When light travels from denser to rarer medium, it bends away from the normal. Here we took denser medium and rarer medium. Light is traveling from denser medium to rarer medium. In that case, it bends away from the normal. Here this is the actual path of the light. Already we know that refractive index of denser medium is greater. So, N2 is less than N1 and speed of light in rarer medium is greater. So, V1 is less than V2. When light travels from denser medium to rarer medium, it bends away from the normal. So, angle of incident angle I is less than angle R. When light travel along normal, then there is no bending of ray of light. It travels without any deviation, but its speed still changes. Here there is a denser medium and rarer medium. Light ray travel along normal, then it travels without any deviation or without any bending. Now, we will discuss about refractive index. Refractive index also called as absolute refractive index. It is represented by eta or mu. The ratio of speed of light in vacuum to speed of light in medium is called refractive index. Refractive index is equal to the speed of light in vacuum by speed of light in medium. Speed of light in vacuum represented by C. Speed of light in medium represented by V. Students, remember speed of light in vacuum is 3 into 10 power 8 meter per second. Refractive index has no units because it is the ratio between speed of light in vacuum and speed of light in medium. Both numerator and denominator are the speed of the light. So, it has no units. Refractive index of water represented by eta W is equal to the speed of light in air by speed of light in water. Speed of light in air or vacuum is equal 3 into 10 power 8. Speed of light in water is equal 2.25 into 10 power 8. Here 10 power 8 get cancelled. 3 by 2.25 is equal to the 1.33. So, refractive index of water is 1.33. Refractive index of glass represented by eta G is equal to the speed of light in vacuum by speed of light in glass. Speed of light in vacuum is 3 into 10 power 8. Speed of light in glass is 2 into 10 power 8. Here 10 power 8 get cancelled. 3 by 2 is equal to the 1.5. So, refractive index of the glass is 1.5. Refractive index of diamond represented by eta D is equal to the speed of light in vacuum by speed of light in diamond. Speed of light in vacuum is equal to the 3 into 10 power 8. Speed of light in diamond is equal to the 1.24 into 10 power 8. Here 10 power 8 get cancelled. 3 by 1.24 is equal to the 2.42. Here we can see refractive indices values of the different media. Among them, air having low refractive index, diamond having high refractive index. Now, we will see relative refractive index. The refractive index of a second medium with respect to first medium is called relative refractive index. Relative refractive index has no units. Relative refractive index eta 21 is equal to the refractive index of second medium by refractive index of first medium. Eta 21 is read as refractive index of second medium with respect to first medium. Here N21 refractive index of second medium with respect to first medium is equal to the refractive index of second medium by refractive index of first medium. So, in place of eta 2 we can write C by V2. In place of eta 1 we can write C by V2. Here C get cancelled. So, we will get 1 by V2 into V1 by 1, that equal to V1 by V2. So, refractive index of second medium with respect to first medium is also equal to speed of light in first medium by speed of light in second medium. Eta 21 is equal to the refractive index of second medium by refractive index of first medium, or speed of light in first medium by speed of light in second medium. Now, we will discuss laws of refraction. Similar to laws of reflection, there are two laws of refraction. First one is the incident ray, the refracted ray, and normal to the interface of two transparent media. At the point of incident, all lie in the same plane. Second one is the ratio of sin of angle of incident to the sin of angle of refraction is constant for the light of given color and for the given pair of media. In case of reflection, angle of incidence is equal to angle of reflection, but in case of refraction, angle of incident is not equal to angle of refraction, but the ratio of sin of angle of incident to the sin of angle of refraction is constant. This law also known as Snell's law of refraction, because it was first formulated by Will-Bode Snellius. So, sin I by sin r is equal to the constant. Sin I by sin r is equal to the refractive index of second medium with respect to first medium, also written as refractive index of second medium by refractive index of first medium. By cross multiplication, we will get N1 sin I is equal to the N2 sin r. This is called Snell's law of refraction. These are the laws of refraction. Students, in this class we discussed reflection and refraction of light, laws of reflection and laws of refraction, and real virtual images. We will continue in next class. Thank you. Have a nice day.